Alright, this is for day 107, reasoning and proof in geometry and in math. We want to use logic to prove things. Sometimes we make up stuff out of, we make up a statement. We're like, yeah, if I go on top of this building and if I jump off, I'm going to fly. No, I'm going to fly. And you're like, no, you're not. Why would I not fly? I say, yeah, I will. Have you ever jumped off a building? Have you? Have you jumped off a building? Liars. I know I will fly if I jump off a... Exactly, I will do that. That's right. See? Someone knows what I'm talking about. Prove to me why I will not fly if I jump off the classroom building.
Gravity.
Oh, the classroom building?
Oh, what was that? Oh, what was that? Gravity.
9.8 meters per second.
Right? What does gravity tell us?
You won't fly.
What does it do? What does gravity do?
Terminal velocity.
Isn't it a law?
Yeah.
Yeah, isn't it a law of gravity, right? We know that things... From science, we know that everything pulls each other to one another. So like a huge mass, like the Earth, right? And it's not even the biggest mass in space. It pulls things to it, right? Because of gravity. Or the sun. The sun is massive compared to the Earth. And it pulls the whole solar system to it, right? And then the Milky Way galaxy is so massive that it pulls in billions upon billions of stars like the sun within it. Which is kind of amazing, right? So... anyways, there's gravity, right? So if I'm going to go say that I'm going to jump off a building and say that I'm going to fly, that's not true, right? That's it. You proved me wrong. Yes, what's up, Tommy?
Is that why it's like when a train is like going fast and there's a person by it? Is that why like the train pulls them?
No, that pulls it because of the air. Yeah, because what ends up happening is that there is lower air pressure by the train, immediately by the train. And so when it's pulling by really fast, that low pressure pulls things toward it. Yeah. Theoretically, there would be a minute amount of gravity toward the mass, but it's not really centralized in a point. Okay. And I'm not like totally certified to teach science, but I understand science pretty well. Anyways, we're going to talk about this, okay? So... if you're on the video, you need to pause it here and write down the title and the objective, please. Okay, here we go. Oh, that's not what I wanted.
Oh, we're done.
No. Okay, so this part's going to be kind of difficult, kids. We're going to go through these, but I need you to write all of these down. I'm sorry.
Shucks.
All of them, okay, in your notes. I'll give you about 3 minutes. Ready, set, and go. Alright, so you should have written these down. So, conjecture, okay? Conjecture is when I make a statement that I believe is to be true. Anyone can make a statement that they believe is true. It doesn't mean that it's true, it's just they believe it's true, okay? For example, remember how I said, oh, if I jump off this building, I'm going to fly. I believe it to be true. But is that really what's going to happen? No, that's right. You give me a counterexample like, well, no, there's this thing, there's law of gravity, you shouldn't jump off the building, you're going to hurt yourself, okay? Right? Now, what about this one? I believe that the sky is blue. Okay? Let's say it's a clear, beautiful day, and I look up at the sky and I say, the sky is blue. That I truly believe it. Is that true?
No. Yes.
Well,
not today.
Right, maybe not today. You could say, well, look outside, the sky is cloudy and gray. And I'm like, oh, yeah, you're right. So you gave me a counterexample, right? Does that make sense? So we're going to talk about that in a moment. The counterexample is down here at the bottom. It's an example that shows a conjecture to be false. So, like I said, the sky is blue. And then Braden said... look outside, it's raining. The sky's gray. I look outside, it's gray. Is it blue today? No, it's gray. Okay? Then we have this thing called deductive reasoning. We have two kinds of reasoning. We have deductive and inductive. Okay, deductive is a process of using logic to prove whether all cases are true. So here we go. Here's a deductive reasoning. Okay, listen. All dogs are yellow. Mr. Rink has a dog. Therefore, Mr. Rink's dog is yellow. Does that make sense? The last statement I deduct from my first two statements, right? Again, all dogs are yellow. Mr. Rink has a dog. Therefore, Mr. Rink's dog is yellow. It's deductive reasoning. Here's another example. Let's see if you could get this, okay? Okay. So, all students are from San Dimas High School. Just listen to the logic. All students are from San Dimas High School. Mr. Rinkowitz has students. Therefore, what? Mr. Rink's students are from... Does that make sense? Okay. Now, I know that that first statement is not true because I know some people maybe from another school down the street called Benita High, and they're here. It's okay. Slowly you will convert. So, yeah. You know you like being there. Yeah. Oh, he can't even look me in the eye. He likes it so much. Okay. Okay. Here we go. So that's deductive reasoning. Inductive reasoning is when we have a law. So here we go. The law of gravity. Law of gravity says that large masses pull things to it. So like the Earth is large mass and it'll pull things to it. Okay, law of gravity. Do we all agree with that law?
Yes.
We all accept it? Yes?
Postulates.
Okay, good. So that's like a postulate, right? So inductive reasoning is us saying, hey, tell me what happens. I'm going to throw a ball up into the sky. What reasoning? Why? How do you know?
Because the law of gravity.
Because the law of gravity says so. It's going to come right back down. It's going to... acceleration of gravity will be applied to it, and then it'll eventually return. Does that make sense? Okay, postulate is a statement that you accept as true. So there's things that are postulates, it's just things that we're like, well, duh, that's just, we all know that. Okay? Okay? So for example, the law of gravity is an example, but we're going to be specific to geometry. A theorem is a statement you could prove as true. Okay, through a series of logical steps. Okay, conditional statement. Okay, here we go. So, here we go. Conditional statement. There's four kinds of statements that are up here on the right. I'm going to erase this other stuff here because I want you to see what I'm going to talk about here. Okay? Here we go. I'm going to give you a conditional statement. It's an if-then statement, okay? So I start with the word if. If, let's see. If students behave, then they go to Disneyland, okay? What's the if part of this? What's the if? What? No. What has to happen before?
They behave.
Students need to behave, right? If they behave, then what's going to happen? What's the consequence? They're going to go to Disneyland. Does that make sense? Okay, so there has to be something that happens, a condition, and then there's a consequence if the condition happens. Does that make sense? That's a conditional statement, okay? Okay, this is like the technical stuff, this is conceptual. So you all have to listen. This is the depth or the big part of our lesson, okay? Converse, okay? Converse, like your shoes, this is not your shoes, but this is what your shoes mean, okay? Converse is when I change things around. So look up here, look what I'm going to do. If they go to Disneyland. If they go to Disneyland, comma, then students behave. What did I do with my statement from the first one? Turn to your group really quick. What did I do with my new statement, my converse statement that's changed from the conditional? Okay, what did I do, everyone? What did I do with my condition and consequence? What did I do? Yeah, I switched them, right? We had if-then statement. So, if we had a condition happen, then we have a consequence, okay? Now, is that true? If students go to Disneyland, then students... Oh, I forgot to put behave. Then students behave. Is that really what happens? It could, I guess, right? All right, so that's the converse. Okay, let me talk to you about this next one. Inverse, okay? It's when we negate both the hypothesis and the conclusion. Watch up here. Everyone focus on the conditional. If students behave, then they go to Disneyland. Okay? Here is the inverse. Okay? Ready? The inverse is if students don't behave, comma, then they don't go to Disneyland. What's the big word that changes everything in this one? Right, then they don't go to Disneyland, right? So if students don't behave, then they don't go to Disneyland, okay? So we're doing the opposite, right, of the original. If students behave, then they go to Disneyland. If they don't behave, then they don't go to Disneyland, okay? Group, talk to them, or talk to your group really quick about the differences between the conditional, converse, and inverse so far. Okay, one more time, 10 seconds, go.
If students, when they go to the conditional statement, they behave, but inverse, if they don't behave.
Okay. Last one we have is the contrapositive. Contrapositive, ready? Okay, this one's going to be even more weird. Okay, ready? Eyes up here. Okay, so the original, if students behave, then they go to Disneyland. Contrapositive, watch what I'm going to do. If they don't go to Disneyland, again, if they don't go to Disneyland, comma, then they don't behave. What did I just do here? Talk to your group. What did I do to make the contrapositive from the original conditional? What did I do? Ready, set, go.
And then
Okay, I heard someone say you do the inverse of the converse. Is that what happens? Did we just do that? Yeah, we do the inverse of the converse. Excellent. Okay. So, I want us to now practice. So I made this one up. I want twos. Twos are all going to raise their hand. Twos, raise your hand. Twos. Twos, you're going to make your own if-then statement. So, like, it doesn't have to be special. Like, in second period, someone made up If you buy a hot dog, then you will eat it. Okay, so make up whatever you like. I don't want you to spend longer than 15 seconds making it up. 2s are making up an if-then statement as the conditional. 3s, raise your hand. 3s. 3s will be making a converse statement of the 2's conditional. 4s, raise your hand. 4s, hands up. Okay, 4s, you're going to make the inverse. You're going to make the inverse of the original conditional. And then 1s, raise your hand. 1s, you're going to make a contrapositive. I'll give you 2 minutes to do that, and I'm going to call on some of you. Ready, set, go. All right, so, okay. Olivia, what did you say as your conditional? Shh, we're all listening.
If I cry, then I will be sad.
Okay. Okay, that's good. That's an if-then statement, condition, okay. All right, Ryan, what's the converse?
If I'm sad, then I will cry.
Okay. What's the inverse? Camilla, what's the inverse? If I cry, then I will be sad. What's the inverse? Uh-huh. Good. If I don't cry, then I won't be sad. Good job. And then contrapositive. Danny. There you go. Perfect. You see how easy that was? Good. Let's have another group. One more group.
Me.
No.
Okay. Celeste group. Celeste, what did you write? If I have ice cream, then I could eat it. Okay, good. Yep, what is the converse? No, if I can eat it. Okay, let's listen. Shh, I can't hear, so. Celeste, one more time. What's your conditional? Tommy, quiet. If I have ice cream, then I could eat it. Okay. What's the converse? No. Listen. If I have ice cream, then I can eat it. Switch them for the converse. If I can eat it, then I have ice cream.
If I can eat it, I have ice cream.
Yep, that's the converse, right? Okay, Christian, what's the inverse?
If I don't have ice cream, I can't eat it.
There you go, good. Yasmin, what's the contrapositive? That's right. Does that make sense?
Good job. Yeah.
Excellent. Okay, you just made your own up. So maybe on a test, I might say, hey, can you make up your own if-then statement and then make up your own converse, inverse, and contrapositive? Do you think you could do that? Yes. You would all have different answers, but at least you would know how to make it, okay? It's logic, right? Now, some of them don't make sense. They don't make logical sense. If I do all my homework, then I will get an A. Okay? Let's just say that's your statement, okay? Is the converse true? If I get an A, then I will do all my homework. Is that always true, the converse? No, that's not really. If I don't do my, tell me this, inverse. If I don't do my homework, then I won't get an A. Is that always true?
Yes.
Generally, yeah. Contrapositive. If I don't get an A, then I won't do my homework.
If I don't get an A.
Then I don't do my. If I don't get an A, then I don't do my homework.
Yeah, that's true.
Okay, it's kind of fun to think about. Oh, that is not where we're going. Here we go. Next one. So let's do some of these together. We're going to go through these quickly. You're like, oh, this is crazy. Ready? Let's do some inductive reasoning. Ready? Number 1, find the next 3 terms of the sequence and talk to your group. What are the next 3 terms? Okay. Okay. What's going on here? What are the next 3, everyone? Why?
It goes up by 2.
Good. Number 2, lesson. Find the next 3 terms of the sequence. -11, -6, -1, 4. What are the next 3? Talk to your group and why.
13, 19, 18. 9, 13, 18.
Okay, what are the next three terms, everyone? 9 what? Uh-huh. Good, why? Good, it goes up by 5. Here we go. So remember counterexample? I said if I jump off the building, then I will fly. And you're like, no, you won't because there's gravity, right? Or a counterexample is, here's another example. I want to make sure we know this. This is a blue marker. Just listen, this is my conjecture. This is a blue marker.
If you're colorblind.
No, not even if. This is what I believe. Okay, give me a counterexample. Give me a counterexample.
That is
This is a yellow pencil.
That is an orange
Oh,
marker.
yeah, that reminds me of.
What does it mean? Like,
Okay.
this is like
Because it draws.
black notebook.
Wait, what do you mean?
Does that mean counter like
That marker is not blue.
Okay, we need to work together if we're going to do this, okay? I know we all want to make stuff up right now. Let's work together. Counterexample. This is this is a blue marker.
That is not it.
Now we're going to go on warning, okay? So now I'm going to put you on warning. This is official now. Trying to get us done. Remember a little bit of time? Okay. Matt, why don't you stay 2 minutes again after class? I asked. You're on warning. Thank you. Okay, perfect. All right, this is an orange marker. This is my conjecture. What would you do to give me a counterexample that this is wrong? Why don't you just say, well, it writes orange, right?
So you say it's a blue marker, right?
Uh-huh.
So then draw blueberries if it's a blue marker.
Right, I couldn't draw blueberries because it's not blue, it's only orange that comes out of it, right? I would have to prove it. Or here's another one. All teachers have a full head of hair. What's the counterexample?
Mr. Ring, look in the mirror.
Exactly. Look in the mirror. That's right. Does that make sense? The example is me, right? Even though it's not mean, it's true. I don't have hair. No, it doesn't. I own the truth, and it's now my strength.
He looks good
Oh,
without
Danny.
hair.
You sound like a priest. Or like a preacher.
Or a teacher. Okay. Okay, ready? Give me a counterexample number 3. Ready? Find a counterexample for the following. All birds can fly. Turn your group.
Penguins can't fly.
Okay, what's a counterexample?
Penguins.
Penguins, right? They're a bird and they can't fly. Good. Number 4. Shh. Find a counterexample for the statement. The sum of two numbers is always greater than either number.
What if a negative?
Talk to your group about it. Give me a counterexample.
True numbers. You're not gonna learn.
Okay, what's my counterexample?
-1 plus, wait, -1. That's
-1. 1 plus a -1.
That's not the sum.
Okay, that's good. -1 plus a -1 is -2, right? Is -2 greater than either of those numbers?
No.
No, so you did it right. Good. Exactly. Someone in second period said 0 plus 0. What's 0 plus 0?
0.
Is 0 bigger than any of the two numbers being added? No. Excellent. Okay, good. Number 5. Now we're switching gears. Not inductive reasoning, deductive reasoning. Remember, earlier I said all dogs are yellow. Mr. Rink has a dog. Therefore what?
This dog's yellow.
Mr. Rink's dog is yellow. Okay, here we go. Number 5. If you live in California, then you live in the United States. I live in Fontana.
Serious?
No. Can we make a conclusion from that?
Fontana's in California.
Montana's far.
That's true. This is we'd have to set up a new statement that Fontana's in California, right?
So therefore you live in the United States.
Yeah.
You live in Fontana and you live in California, then you live in the
Good. So this one's a little detached, but that one's good. Next one, number 6. I will do better on my test. I will do better on my test if I do my homework each night. Here's the second statement. I did all my homework for this chapter.
So therefore I did
What's the conclusion?
I did all my homework.
which is part of the
Okay, looks like we're gonna stay another minute. Okay, so hey, all I need you to do is focus. It's not even that you were like, I don't mind the talking. You're just not talking about math. Some of you are talking about your T-shirt or something, some stain there. I don't know what's going on. Others are talking about something else. Okay, here we go. So number 6 again. I will do better on my test if I do my homework each night. Here's the second statement. I did all my homework for this chapter. Will I do better on the test?
Yes.
Did I do homework each night?
Yes.
No. So can we prove that I'm going to do better on the test?
No.
No. So you see how that works? It has to connect perfectly. Like the example of the dog. All dogs are yellow. Mr. Rink has a dog. Therefore, Mr. Rink's dog is yellow. That works perfectly, right?
Do you have a dog?
Yeah. Okay. Here we go. One more example, then we're done. Here's the conditional. Because you have a minute. Don't pack. Okay, you want to wait 2 minutes? That's fine.
No.
Yeah. You just got to chill and focus right now, okay? Here we go. Ready? Turn to your neighbors. The conditional statement is if 2 lines never cross, then they are parallel lines. Please provide your neighbors converse, inverse, and contrapositive of this one. Ready, set, go.
If they're parallel lines, then
They're not parallel.
don't let 10 on. If 2 lines cross, then it's not.